All right, welcome back. Today's lesson's on solving rational equations. And now technically this first example I've given you here is not technically a rational equation because there's no value of a variable in the denominator. But let's pretend it is for one second because we're going to use this idea. If I gave you the fraction 3/5 equals x fifths, you might recognize this as a proportion where we could cross multiply, right? And then set their products equal and solve, right? I could say 5 times x equals 3 times 5, and we could find that x is 3. Okay, however, there's obviously a much simpler way of doing that same problem, right? If we notice, if the denominators, if they're both in the same size of fifths, and this has 3 of them, and this has x of them, for these values to be equal, if our denominators are already equal, then we can kind of ignore them and figure out what makes the numerators equal. And in this case, x has to equal 3. We can go straight to our answer without having to do cross multiplication or a bunch of additional work. And this is the idea that we're going to use to help us with more complicated expressions. Okay, if all denominators of the equation are equal, then the equation that exists in the numerators contains all of our possible solutions, excluding any restricted values. So if we have values to get rid of in our domain, right, things that make the denominator 0, we'd have to throw them out of any potential answer. They'd be extraneous solutions. Okay, so I have a bunch of steps here. I'm going to go through them as we go through this first example. Okay, so solve, state any domain restrictions, and be sure to check your solution against your restrictions. So typically we'd want to take all of our denominators and factor them out. Okay, in this case they're all as small as we could possibly make them, x2 and x. So the first thing we want to do is find, or the second thing I should say, is find the least common denominator. Okay, so notice 2 of these already share an x, and I don't want to make this any bigger than possible, so let's include one x in our LCD. And notice we also have a term that has a 2. So we have to have at least one 2. So our least common denominator is x times 2, or 2x. So this is the denominator we want to give every fraction here. So we're going to put every fraction over our common denominator, 2x. Okay, and then we're going to go ahead and make equivalent fractions, right? We may need to multiply the top and bottom of them by something to achieve this common denominator. Well, this first one already has the x. It needs to be multiplied top and bottom by the other missing factor from our least common denominator of 2. And 4 times 2 is 8. Our second fraction needs to be multiplied top and bottom by x to get to 2x, and that gives us 5x in the numerator. Our last one already has the x, so we need to multiply top and bottom by 2, and that gives me negative 22. Okay, now notice we've now made all of our denominators equal and made our equivalent fractions. We can now write our domain restrictions. Okay, so this is step 3. And in this case, what value or values of x make the denominator 0? Well, there's 2 factors here. 2 will never equal 0. But if x itself equals 0, we'd have division by 0. So my domain is that x cannot equal 0. Okay, now I usually say to highlight this or make it stand out in some way. I'm going to box it in because when we get our final answers, we always want to check them against this and make sure we don't have a restricted value as an answer. Okay, so now what we can do is we actually get to ignore the denominators that are all the same, and we can finish by solving the equation up top. If I solve the equation, 8 plus 5x equals negative 22, this value of x should give me my solution. So we're going to subtract 8 over, 5x equals negative 30, and dividing by 5, we get x is negative 6. So before I mark that as my final solution, I do want to check it against my domain. And in this case, it is not a restricted value. So our solution is negative 6. Negative 6 is the value that will make this equation true. All right, here's our next one. Again, one of the things we want to do is find our least common denominator first, and that helps us by factoring all denominators when possible. So we can even think of 8x as being 2 times 2 times 2 times x. Anything that is not a fraction, like say this 4 or negative 4, let's put that over 1. So I do have a denominator of 1 there, and then we have 2 times x. So when we go to make our least common denominator, remember anything they already share, like a 2 and an x, we don't want to list a repeated number of times. So let's put 1, 2, and x that some of them already share in there. But now everything that's not common to all fractions needs to also be a part of our LCD. Again, we can't make it smaller unless any of these original fractions were reducible, and they're not. So we do have 2 2's and a 1. 2 2's and a 1. And of course, 1 being a 1, we could probably ignore that, but just for the sake of saying we included it, it's there. So our smallest possible common denominator is 8x, multiplying them back together. So let's give everything a common denominator of 8x. All right, so we've set up our common denominator. Notice, of course, our first fraction already had our common denominator, so we don't need to change that at all. However, our second fraction didn't have our common denominator at all. And all of the factors it's missing is basically 8x, right? We need to multiply it top and bottom by 8x. Now, here's a part where things could get complicated. And we usually say to change subtraction to adding the opposite. And that's a good idea here because I'm really going to be doing negative 4. So we're actually going to go ahead and change this to addition. Negative 4 times 8x. Now the reason I want to put that negative with that 4 is that negative sign would need to be distributed if we had more terms to multiply it by. So just to be on the safe side there, we'll put it in parentheses, and we're going to make this negative 32x. Negative 32x. Okay, and again, I just changed it to adding the opposite, negative 4 times 8x, negative 32x. Of course, technically we multiplied the bottom by 8x. Our last one here, notice it's already got the 2 and the x, so it needs to be multiplied by 4, top and bottom. So times 4, top and bottom. And that gives us 20 as our equivalent fraction, 20 over 8x. Okay, before we go getting rid of these denominators, we're going to state our domain restrictions. The only value that will ever make the denominator 0, 8 will never be 0, but x directly could be 0. So our domain is that x can't equal 0 again. So again, highlight that, circle it, box it in, make it stand out so you remember to check your answer against it. Next up, let's go ahead and get rid of our common denominators now, because we know that whatever makes the numerators equal will answer our equation. When does 3 plus negative 32 or minus 32x equal 20? Subtract 3 from both sides. We get negative 32x equals 17. And if we divide by negative 32, we get negative 17/32. I just moved the negative sign up top, but you could keep it down below if you want. Check that, of course, against my domain. We don't have a restricted value, so that should be our solution. Okay, here's a third example. So once again, I notice we have something that's not a fraction, so let's go ahead and give that a denominator. And then we would try to factor our denominators to find our least common denominator. However, our other two expressions cannot be factored, so we'll think of them as their own factors. So my least common denominator here, again, I like to list everything they already have in common. And 2 of them already have an x minus 2, so we're only going to need 1 of those. And then, of course, the uncommon factors here is just 1. So 1 times x minus 2, or x minus 2, is our least common denominator. So we'd want to put them all over x minus 2. So we'd set up all of our fractions here, all over x minus 2. And then we'd figure out what we need to multiply the tops by if necessary to get there. Well, of course, our first one has the common denominator already, so we don't need to change it. It stays 5x. Our second one, though, needs to be multiplied by the entire expression, x minus 2. Okay, notice I always put parentheses around the top here because we may need to say FOIL or double distribute or something for some other instances. Here, though, it is 7 times that quantity, 7x minus 14. Our last denominator here does not need to be changed, so we can keep the numerator of 10. So now I take a look at our least common denominator. What would make the denominator 0? In this case, positive 2. So x cannot equal positive 2. There is my domain restriction. Box it in, highlight it, or circle it, so remember to check our answer against it. So now we get to get rid of that common denominator and solve the equation up top. So when does 5x equal 7x minus 14 plus 10? Well, of course, we can go ahead and simplify two of those values over here. Negative 14 and 10 make negative 4. Let's subtract the 7x to the other side. We get negative 2x equals negative 4. And if we divide both sides by negative 2, we get x is 2. Before we mark that as our answer, though, check your domain restriction. And notice x cannot equal 2. We'd have division by 0. Well, this is the only possible solution we came to algebraically, but it's a restricted value. So in this case, we need to throw this answer out. And because there was only one possible answer, that means this problem has no solution. And there's the symbol to represent no solution. So there is no real value of x that ever makes this equation true. There is no solution as our final answer there. Okay, let's look at a fourth example. This time we will have to do a little bit more factoring, maybe in our denominators. Again, this 3, go ahead and put that over to 1, just to remember that we also need to give it an equivalent denominator. So if we were factoring our denominators, nothing I can do with the first one, but hopefully you recognize our second one is a difference of squares, x plus 1 times x minus 1. So as we look at our 3 denominators to help determine our least possible common denominator, I notice 2 of them have an x plus 1, so we'll need just one x plus 1 in our LCD. And nothing else is in common. So we're going to go ahead and list things that were uncommon, like x minus 1 and our 1. So we can say our LCD needs to have an x plus 1 and an x minus 1. We can kind of ignore the times 1, of course. Okay, so that's the least common denominator. So we'd set up the denominators for all of these, x plus 1, x minus 1. X plus 1, x minus 1 for all 3 fractions. I apologize, my handwriting is for some reason getting gradually worse today. X plus 1, x minus 1. Okay, so our first fraction, it does have the x plus 1, but it doesn't have the x minus 1. So what we need to do is multiply the entire numerator and denominator by x minus 1. And yes, we do need to FOIL this out. Again, that's why it's a good idea to put parentheses here. So 4x times x is 4x squared. 4x times negative 1, negative 4x. 1 times x is x. And 1 times negative 1 is negative 1. Okay, our next one actually already has the common denominator, so we don't need to change that fraction at all. However, our last one does need both x plus 1 and x minus 1. Well, I already know what they look like when they're multiplied together. It's really equivalent to x squared minus 1. So I'm going to go ahead and just distribute an x squared minus 1 to the top, because I know that's equivalent to x plus 1 times x minus 1. So this is going to give us 3x squared minus 3. Okay, so now we're going to go ahead and state any domain restrictions here. Looking at our denominator, x cannot equal negative 1 or positive 1. So 2 restrictions. We'll list those out and highlight them, box them in, whatever we can to make them stand out, so remember to check our answer. And now we can get rid of these denominators. See you later. Now we have an equation to solve up top. And hopefully we recognize that we actually have a quadratic. We've got some x squareds floating around, we've got some x to the firsts, and we've got some constants. And if we're solving a quadratic either by factoring, quadratic formula, most of our methods require us to set it equal to 0, and usually we want to keep x squared positive. So I think my goal is to move everything to the left side of the equation. So I'm just going to write this out, simplifying each side first. 4x squared, I'm going to go ahead and combine these x's here. Negative 4x and x makes negative 3x minus 1 equals, and I'm going to go ahead and also combine positive 12 and negative 3, which would make positive 9. Okay, so just combining the few like terms on each side. Now let's go ahead and move the 3x squared over, and let's move the 9 over to set our equation equal to 0. So we end up with x squared minus 3x minus 10 equals 0. And luckily for us, this quadratic does factor. It factors as x minus 5 times x plus 2, which gives us the two possible solutions of positive 5 and negative 2. So we need to check our answers. Remember to check them against the domain, and neither one is a restricted value. So in fact, this has two values of x that make the equation true. Positive 5 and negative 2 are both solutions to this problem. Okay, I'm skipping over a few examples to try to save us some time because this video could be very long. Well, let's get into some word problems that use these types of equations. So here's some basketball statistics. So far in the basketball season, you've made only 4 free throws out of the 10 you have attempted, for a shooting percentage of 40%. Not great. How many consecutive, meaning in a row, free throw shots would you have to make in order to raise your free throw shooting percentage to a more respectable 70%? Okay, well, we're assuming you're probably not a center or something here, but you're trying to get up to 70%. You've already made 4 out of 10. So of course, if you did the division there, right, 4, let's say this is makes out of 10 attempts, right? Most of you guys would know, of course, that when we divide that, that gives me 40%. Well, let's do a couple more steps here to figure out what's going on. Let's say I make my next attempt. So I now have 5 makes out of 11 attempts, which would make my percentage a little bit higher. If I make my next shot, I would have made 6 shots out of 12 attempts. If I make my next attempt, my make goes up by 1, and my attempts goes up by 1. And this just keeps happening, of course, right? 8 out of 14, etc. So here's the pattern, right? As the denominator, as the number of attempts goes up by 1, my makes is going up by 1 if I'm making them consecutively, meaning in a row. So from this, we can set up an equation. But keep in mind, this starting fraction, we have to keep it and you cannot reduce it. Okay, and there's good reason for that. 2 out of 5 attempts is easier to get your percentage up than if you've made a lot of shots already, right? For instance, if you've only made 40 out of 100, it's going to be much harder to get your percentage up to 70. So hopefully that makes sense why you cannot simplify that here. Okay, but what I know is if I take my 4 out of 10 and we increase them by some number. So if my makes goes up by some number and my attempts goes up by the same number, because remember these are going up, right? Each adding 1 to get to the next number. So they're each increasing by the same number. Do I need to make 2 in a row or 3 in a row or 4 in a row from where I'm at, right? To get up to this 70%. So that's what we're saying. What is that number? How many in a row, my attempts and my makes go up by the same number? When will that equal 70%? Which you could represent as a fraction, 70 out of 100. You could simplify that fraction because, again, the percentage can be represented by a smaller value. You could say 7 out of 10. This is okay to reduce, but your starting fraction is not. Again, for why we discussed earlier, easier to get your percentage up if you've only made 5 attempts, 2 out of 5, than 40 out of 100, right? Those are very different starting places. So here's our equation. And if we wanted to solve this, this is a rational function. So let's give them common denominators. Now I can't really factor either denominator out much, right? And they don't have anything in common, which means my least common denominator here is going to need to have a 10 and a 10 plus x. Now if you wanted to write that the other way, x plus 10, that's fine. I'm just going to keep the format we have it set up with. So this is my least common denominator. So let's give everything our common denominator, 10 times 10 plus x, on both sides here, 10 times 10 plus x. Okay, well, our first fraction, of course, has the 10 plus x. It's missing the 10. So we need to multiply top and bottom by 10. Don't forget to put parentheses around the top to remind yourself to distribute. That will give me a new numerator of 40 plus 10x. Well, our second one only has the 10. It's missing the 10 plus x, so we need to multiply top and bottom by 10 plus x to achieve our common denominator. So distributing here, we're going to get 70 plus 7x. Okay, now usually we won't run into a restricted value here, but we're going to go ahead and write our domain anyway, of course. No values of x will make 10 0, but in this case, negative 10 would make our second factor 0. So the number of attempts in a row I can't make is negative 10. In fact, we could definitely mathematically or logically exclude negative numbers in general, right? Including 0 from our possible values. But we'll go ahead and say mathematically, of course, for our equation, we need to get rid of at least negative 10. But yes, we should also really be getting rid of all negative numbers. I can't make a negative number of baskets in a row. That doesn't make sense, etc. But now let's go ahead and solve the equation up top. We've got 40 plus 10x equals 70 plus 7x. So let's move our x's on one side. I'm going to move the 7x over, which will give me 3x. And I'm also going to go ahead and move the 40 over to the opposite side by subtracting it over, which would give me 30. Dividing by 3, we end up with that we need to make our next 10 shots in a row to get up to 70%. Well, how can I check that? Let's add 10 to our number of makes and 10 to our number of attempts. So if my makes goes up by 10, that would have been 14, right? Again, from our start. If my attempts goes up by 10, that would be out of 20. And you might notice that if you reduce this by dividing by 2, that would give me 7/10, which is a fraction equivalent to 70%. So that's it. We need to make 10 in a row to get up to 70%.